In Math Lesson 1-6, we're going to be exploring non-standard volume units. And part of this we will not do. You'll notice a journal page that we needed pattern blocks and prisms, and I just don't have those materials to send home. But let's go ahead and start with a warm-up. You'll need your whiteboard marker, and eraser. Don't forget to keep those things right next to your work area along with that math journal. So let's go ahead with our whiteboards and number 1, 2, and number 3 on your whiteboard. We're going to talk a little bit about meters and centimeters this morning in our warm-up. If you can remember back to your classroom, last time you were in one, a meter stick, here's a picture of it. Just to let you know that 1 meter equals 100 centimeters. And I know that picture of the little boy is a little blurry, but you can see he's holding a meter stick, a little taller than the chair and up to about his chest. So on number 1, would you write 1 meter equals how many centimeters? Hint, hint. Then for number 2, 2 meters equals how many centimeters? And 3 meters, how many centimeters does that equal? Go ahead and write that on your whiteboard. Remember to pause the video as needed. All right, number 1, I pretty much did for you. 1 meter equals 100 centimeters. 2 meters equals 200 centimeters. So all I did was to take 100 centimeters, multiplying that by 2. So 3 meters would be 300 centimeters. And we want to make sure we keep that label on there of either M for meters or cm for centimeters. Go ahead and erase number 1, 2, and 3 again. Keeping in mind that there are 100 centimeters in 1 meter. So for 14 meters, how many centimeters would that be? 900 centimeters equals how many meters? And 2,400 centimeters equals how many meters? Go ahead and pause your video and write down your answers. Okay, so 14 times 100 would be 1,400 centimeters. 900 centimeters equals how many meters? Well, 100 would be 1. One more would be 200. And I could keep going, 300. I would end up getting 9 meters. And 2,400 centimeters, if I take 2,400 and divide that by 100 centimeters in every meter, watch what happens. These zeros cancel each other out. 24 meters. All right, erase your whiteboard and one more warm up with centimeters and meters. This time we have less than a full meter in each of these problems. So 50 centimeters equals how many meters? 850 centimeters equals how many meters? And 1/4 of a meter equals how many centimeters? So you can write this as a decimal. Go ahead and pause your video. Make sure you're doing this with me. We're expecting growth over time this year, and the way that you're going to grow is actually doing and not just watching. 50 centimeters would be 50 hundredths of a meter, so less than 1 full meter. 850 equals how many meters? Well, I know that 100 would equal 1. 800, just to let you know my thinking, centimeters would equal 8 meters. 900 centimeters would equal 9 meters. So 850 would be between 8 and 9 meters. So it would be 8 and 50 hundredths of a meter. And 1/4, well, what is 1/4 of 100? So if you think of $1, if you had 100 pennies, what would be 1/4 of them? Another way to say that would be 25 hundredths of a meter. I think of quarters is worth 25 cents. I want you to go ahead on your whiteboard and draw a rectangle. I want you to think about what you would need to do if somebody asked you to find the volume of your rectangle. You don't have to record your ideas, but I want you to think about it. Volume. What did you learn about volume the other day? Think about that for a second. Could you figure out the volume? Remember, we found that the volume is the amount of space inside a solid figure, but the figure has to be three-dimensional. Right now, this is two-dimensional, isn't it? It's flat. So in order to figure out volume, you need to have three things. Would you please write on your whiteboard, what are the three words that we used the other day that we would figure out volume? Well, first of all, you would need length, right? We have length right now. This would be the length. We need a width, which would be this. What are we missing? Well, we're missing the height. This is a flat object. So in order to do that, I would have to have a three-dimensional shape. So we're going to work a little bit more just on area of flat rectangles, not three-dimensional. So you're going to go ahead and open up your math journal to page 16. On page 16, we're going to find the area of each of these rectangles. When we found area the other day, we knew that we could count up the squares if there were square units. And in this case, it's square inches on our first one. You could count those. You could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Together, this would be 11, 12, 12 and a half square inches. As we know that sometimes rooms or whatever we're measuring does not measure to an exact inch or an exact meter. It often is a portion of one. Number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 and 1/3, 12 and 2/3, 12 and 3/3. Remember, when our fraction has the same number in the numerator as the denominator equals 1 whole. So together we would have 13 square meters. I'm going to use that formula that we talked about, which is length times width. The length is 6. The width is 3 1/4. So remember, I'm going to take the whole number times the whole number. 6 times 3 is 18, and then take my whole number times the fraction. 6 times 1 is 6. I keep the denominator the same. But remember, we don't want to leave that as an improper fraction. We want to convert that to a mixed number. So 6/4, I know if I take 4/4 from that, because 4/4 would equal 1 whole, I'm going to add the 4/4 to 18 to get 19. And then when I subtract the 4 from that, I'm left with 2/4. So we would say that area would be 19 2/4. Make sure that you are completing this when I am during the video. Stop it or pause it as needed. We also, what's another way to say 2/4? We could say 19 1/2. If I said I ran 2/4 of a mile, that probably isn't what I would say. I would typically say a half a mile. All right, number 4, let's do the same thing. Let's take length times width. I'm going to start with the whole number, 6 times 2 1/5. So the first thing I'm going to do is multiply the whole numbers. 6 times 2 is 12. And then I'm going to take the whole number times the fraction. Remember, the denominator stays the same, so we know it's going to be fifths. 6 times 1 is 6. Again, that's an improper fraction. I know I can take 5/5 away from that to equal 1 whole, and I would add that to the 12. And then when I subtracted 5/5 from that, 6 minus 5 is 1/5. I would be left with 1/5. 13 and 1/5. At the very bottom, we have try this. Number 5A, what is the area of this rectangle if the sides of the square are 1 unit long? So if we go 1 unit, we just have to count 1, 2, 3, 4, 5. And then the width is 1, 2, 3, 4, 5, 6, 7, 8, 9. The area is length times width. 9 times 5 is what? 45 square units. B, what is the area of this rectangle if the sides of the square are each 1/3 unit long? So I'm going to count by thirds. 1/3, 2/3, 3/3, or 1 whole. 1 1/3, 1 2/3. Let's count going the width. We're going to count by thirds. 1/3, 2/3, 3/3, which is 1 whole. 1 1/3, 1 2/3, 1 3/3, which is the same as 2. 2 1/3, 2 2/3, 2 3/3, which would be the same as 3. Now I'm going to take length times width. 3 times 1 2/3. Remember, whatever I write, you are writing as well. I would multiply the two whole numbers. 3 times 1 equals 3. Now I will multiply the whole number times the fraction. Remember, thirds will not change. It will stay thirds. So the whole number 3 times 2 is 6. Now 6/3 is an improper fraction. 3/3 is equal to 1. Another 3/3 would be 6/3. So this is equal to the whole number 2. So I'll add that together. 3 plus 2 is 5 square units. Go ahead and check Schoology to finish the lesson for today.